Hello there, this is Miss Nakayama, and today's lesson is 6.5, Complex Numbers in Polar Form and DeMoivre's Theorem. This is the last lesson that we're going to cover in polar coordinates this year. It is not hard. The process in each of these problems is not hard, but you need to practice them. So hopefully you'll understand how important it is to do your homework assignment. So what we're going to cover in today's video, we're going to plot complex numbers. We're going to find the absolute value of them. We're going to write them in polar form. We're going to convert back and forth between polar and rectangular. We did a lot of that with real numbers before. Now we're doing it with complex numbers. Okay? And then we're going to find the products, quotients, powers, and roots of complex numbers in polar form, because it's much easier to do it in polar form than it is rectangular form. So, first off, what is the complex plane? Remember, a complex number looks like z equals a plus bi. So z is often the letter used to represent a complex number, a plus bi. It can represent a point in a coordinate plane, that point being a comma b. If you think of the horizontal axis being the real axis, the A, where you would plot A, and the vertical axis being the imaginary axis, where you would plot the B. That coordinate system is referred to as the complex plane. So this point that I have in here now is z equal to a plus bi. I went a units on the real axis and up b units on the imaginary axis, which is why it looks like that ordered pair. Again, not hard. We're going to go do some examples here. All right, first example, we're going to plot each of these. And you can see I've actually plotted all of the points, but let's hope we have no trouble finding out which one's A, B, C, D, and E. So if you're really good, pause it, see if you can get it right, and then click back and check your answers. So 2 plus 5i, they're both positive, so over 2 up 5 is going to put point A right there. B, negative 4 minus 3i, they're both negative, so I'm going to go negative 4 and then down 3. So to the left and down is going to make this point B. C is 2 minus I square roots of 3. So I'm going to the right 2 and then down the square root of 3. Well, the square root of 3 is equal to 1.732. So that's about 1.732. And that makes that point C. Now, these two, don't get confused, but negative 6i, that's like 0 minus 6i. So I'm just going to negative 6 on the imaginary axis, which makes that point D. And E, which is negative 3, is going to be negative 3 on the real axis, and that makes, oh, goodness. Well, that wasn't confusing at all. Where was I? Right here. This is point E. Okay. So, again, not very hard. Let's go to the absolute value of a complex number. Again, this is not hard, but if you don't remember the vocab, y'all, and practice the questions in your homework, then it's going to be challenging. So the absolute value, just like it does in our real number system, represents the distance from the origin. Okay? So if you look at this picture here, A and B, do you know how to find this length? Well, you do, because y'all are all saying it's the Pythagorean theorem. So it's represented as the absolute value of z, which is the absolute value of a plus bi. And I'm showing that to you so you need to understand that when you see that, this is what it's asking. It's asking for the hypotenuse of that triangle, which is just the square root of a squared plus b squared. You know this. You know the Pythagorean theorem. You know the hypotenuse. You just have to know the vocab to make sure you know what it's asking. All right, so here's two examples. We have determine the absolute value of the following complex numbers. So I just talked about that on the page before. Z is 5 plus 12i. All right, and the best way to learn this, y'all, is to, of course, write it down every time you do a problem. So if I have the absolute value is the square root of a squared plus b squared, then a is 5 and b is 12. Y'all, well, and this problem doesn't matter so much, so I'll just keep on going. So in this case, as I said, a is 5, b is 12. 5 squared plus 12 squared is 169. The square root of 169 is 13. Now, when I go to the next problem, z equals 2 minus 3i. If you've listened to me enough, you know that I am really big of whenever you have to plug in a negative number to put parentheses. But I also tell you over and over again that if you're going to square a number, it's always positive. So in this case, I don't have to worry about the negative. But if you're going to insist upon putting a negative number in here, you need to put parentheses around it because you're going to put it in your calculator wrong and then get it wrong. So I choose to not, because I remember that squaring a number is always positive. So I'm going to have 2 squared plus 3 squared, which is going to be the square root of 13. And that doesn't simplify, so I leave my answer like that. All right, polar form of a complex number. A complex number, we've already talked about that, z equals a plus bi, is in rectangular form. We had this before. We went from rectangular to polar, okay? So before our rectangular form, y'all dealt with x and y, but we call it a and b when it's a complex number, okay? Now, that complex number in polar form, the polar form of a complex number, is written like this: z equals r parentheses cosine of theta plus I sine theta. You can also write that in an abbreviated form, and y'all don't like to write more than you have to, so I'm going to tell you this, as r cis theta. So the cis is an abbreviation of cosine I sine. Always a plus sign between the two of them. Okay? Now, we're using the same formulas, y'all, that we used before with real numbers. We're going to use those same formulas when we're talking about the polar form of complex numbers. So we know to go back and forth. A is r cosine theta. Well, before it was x. So y, well, we're not going to talk about y. We're going to talk about b is equal to r sine theta. Okay, r is the square root of a squared plus b squared. We just talked about that. And the tangent of theta is b over a. So if you can just remember, okay, that a is like x and b is like, well, that doesn't look right. B is like y that we had before, then you already know these formulas and it's nothing new. You do need to be familiar so that you can answer the questions. R is called the modulus, and ain't not working. Don't do this to me. Uh-oh. Well, now. Okay, let's just do this. There we go. R is called the modulus, and theta is called the argument. Okay, so writing a complex number in polar form, what do you have to be able to do? All right, so we've got z equals negative r times the, z equals negative 1 minus r, no, why do I keep saying r? Z equals negative 1 minus I square roots of 3. Okay, first off, they want us to plot that number in the complex plane. So negative, negative, you need to think that's going to be in the third quadrant. Okay, so negative 1, I'm going to go to the left. We kind of did this already on a previous slide. I'm going to go to the left 1 and then down square root of 3, which is about 1.37. 1.732. So that's where it plots. All right. Then remember that this is a plus bi, and if they want it in polar form, I have to have r and theta. Because it's a complex number, I'm writing r cis theta. Okay, and just to remind myself what I'm going to. Okay, they gave it to me in rectangular. I'm trying to put it in polar. So I need to find r, and r is the square root of a squared plus b squared. So that's a is my negative 1, but I'm not going to write the negative because I'm squaring it. So that's 1 squared plus the square root of 3 squared. And that, put it in your calculator if you cannot do it in your head, is equal to 2. So r is equal to 2. And then I've got to go find the tangent. And the tangent is b over a. All right, and b over a. In this case, y'all, I'm not squaring anything, so you absolutely have to write the negatives in this. And you need to think about what quadrant it's in. So the tangent of theta, or theta, is equal to, I'm going to write it like this so that you remember to use that button on your calculator. Theta is the inverse tangent of b is negative square root of 3, and a is negative 1. We already saw, we plotted that in the third quadrant, okay? But if you put that in your calculator, you're going to get pi over 3. You do have to put it in radians every time, so you need to know that 60-degree angle is pi over 3. But as I said, you always have to remember what quadrant it's in, and it's in quadrant 3, and in quadrant 3, the pi over 3 angle is 4 pi over 3. So my answer, the answer to this problem, and writing, trying to get up here and he won't let me, in polar form is going to be r cis theta is going to be 2 times the cosine of 4 pi over 3 plus I times the sine of 4 pi over 3. I think that's how you have to put it in MyLab Math, y'all, like this. I don't know that it will accept the abbreviated form, but I do want you to be familiar with it. And you might write it in your work like that. You can write it on your lesson check like that, and in your homework. But when you put it in MyLab Math, you got to write it like that. Okay. So next, the product of two complex numbers. So if I show you the formula, y'all, you might think that looks really complicated. Here's the formula, okay? But really, it's not that hard. To multiply two complex numbers, you multiply the moduli and add the arguments. If you don't remember those vocab words, that means you're going to multiply the r's and add the thetas. Multiply the r's, add the thetas. So multiply the r's, add the thetas. We got, find the product of the complex number. Leave your answer in polar form. This is kind of important. So polar form means I can leave the r cis theta. I can leave it in r and theta form. So if I'm doing z1 times z2, I'm doing 6 times 5, and then I'm doing cis 40 plus 20. That's all you got to do. And when you answer that, that's 6 times 5 is 30. 40 plus 20 is 60. 30 cis 60 degrees. Again, in MyLab Math, you might have to type out cosine 60 plus I sine of 60, but that's all it is. All right, that's the product. If we multiplied r's and added the thetas when we found a product, what do you think we're going to do? We find the quotient. Again, a little messy looking. But to find the quotient, if you can look at that, to divide two complex numbers, you're going to divide the moduli and subtract the arguments. In other words, divide the r's and subtract the thetas. So here's an example. Find the quotient of the following complex numbers. Again, leave your answer in polar form. So z1 divided by z2 is going to be, there we go. Y'all, this would be something that people do mess up on. We read from left to right and top to bottom. So it is going to be 50 divided by 5, not 5 divided by 50. Okay? So 50 divided by 5, cis 4 pi over 3 minus pi over 3. Your calculator will do that for you. And when you subtract, you're going to get 10 cis pi, because 4 pi over 3 minus pi over 3 is pi. Okay? All right. Oh, my goodness. Why? Why, oh, why? All right, where was I? I did that one. It's just not liking me. All right, DeMoivre's theorem. We're so close to the end. All right, and DeMoivre's theorem says, y'all, it's an application of multiplying, okay? If you're raising something to a power, okay, an exponent is just an example of repeated multiplication. So it looks like this, which can be a little scary or daunting, okay? But let's go down and really analyze it. Z to the n is just r to the n. Well, the whole thing, I'm writing r cis theta. That means I'm going to raise r to the n, and then I'm going to multiply theta times n. So that's what happens. All right, so it's just, if you just, that to me is an easier way for you to remember, or just this much is easier for you to remember than all of that. So I'm hoping that's what the abbreviated form will help you do. All right, so look at this guy. We know that r cis theta to the n is equal to r to the n cis n theta. All right, but this time, y'all, we actually have to write, it's not letting me change anything. No, it won't let me. Oh, maybe if I do it like that. Okay. We have to write our answers in rectangular form this time. So I can't leave it as r cis theta. I have to write it as a plus bi. So we're going to go through and do that. But you just have to pay attention to the directions and what they ask. So in my abbreviated form, I have 2 cis 30 all raised to the 5th. And that's going to be 2 to the 5th cis 5 times 30. 2 to the 5th is 32. 5 times 30 is 150. Okay, so that means this is 32 cosine of 150 plus I sine of 150, because I was just abbreviating with the cis. To get it into rectangular form, y'all, go figure out what the cosine of 150. So notice the difference. This is polar form and this is rectangular. There is no cosine or sine here. So that just means I'm going to evaluate the cosine of 150 and the sine of 150. So what is that? Well, cosine of 150 is negative square root of 3 over 2 plus sine of 150 is 1/2, and I put the I afterwards. And then all you have to do is to distribute the 32. So that's going to give me negative 16 square root of 3 plus 16i. And that's all you got. All right. Now, to go backwards with that is finding the root. And y'all, I'm going to show you something that I think is a lot easier than all of this. But those of y'all who like to look at the example in MyLab Math, this is what you'll have to look at. And I'll let you figure it out there. But I'm going to show you a little bit shorter way. I am still using, I'm kind of using a variation of DeMoivre's theorem. You're going to see this. Okay. They're asking us to find the roots of a complex number. Find all the complex fourth roots. Okay, if I'm finding the fourth root of a number, y'all, that means n is equal to 1/4. When I raised it to the 4th power, n was 4. So the fourth root means n is 1/4. So that means this complex number of 16 cosine 60 plus I sine 60 is just, oh poo, go away, is just 16 cis 60 raised to the 1/4. So if you apply DeMoivre's theorem that we just did, that means that's 16 to the 1/4 cis 1/4 times 60. And that gives me, I goofed on that one. Gives me 2 cis 15. Okay? One of the things that you have to remember, though, this is something that's new, and that's why they had all that gibberish up in the slide before. But when you're finding the roots, if it's 1/4, you're going to have 4 answers. If it's 1/3, you're going to have 3 answers. If it's 1/6, you're going to have 6 answers. How do you find all those answers? Well, you take that number 4 and divide it into 360, and you get 90. So I'm going to add 90 to each of these. My box covered that up. All right, so when I add 90 to the 15, I'm going to get 2 cis 105. And then I add 90 again, and I get 2 cis 195. And add 90 again, and I'm going to get 2 cis 285. And those are all 4 of my answers. Okay? The last thing I want to leave you with, y'all, is a summary to kind of help you keep things straight, because this can be confusing for people. So what we talked about previously, this little chart, is you might write it down just to keep things straight. But when you're talking about real numbers, our answers, rectangular form of real numbers, are x and y. Our polar form of real numbers are r and theta. Okay? When you get into complex, okay, then we have a plus bi for rectangular form. And for polar form, we have r parentheses cosine theta plus I sine theta, or r cis theta. So again, just a summary, just a way to help you keep things straight. If you're talking about real numbers, there's no I in either one. Complex numbers has an I in both of them. Okay? So, hope you enjoyed watching that. That was the last lesson that we have on polar coordinates. Thank you so much for watching, and y'all have a great day.